Hello and welcome to Collyers. I'm Charlie and this is Tom, and we're co-directors for this video.
Before we start, I want to thank you very much for the opportunity to be a part of this competition. It's been great fun to have the robot to work on, and especially towards an overarching goal.
Yeah, throughout the video we're going to introduce you to some of our progress, our prototypes and our design process.
And we want to show you how we feel we are the team that should be representing the UK in the first global competition.
We work on a spiral development model where we prototype systems, then test these and refine until we're happy with the prototype. We used a modular system to incorporate other parts of the main robot. For example, our sorting system we developed entirely separate to the actual robot itself, and then found a way to introduce it to the robot.
Hi, welcome to our robotics room. At the moment at our college we've got a whole room sort of dedicated to just this team, which allows us to have a sort of whole whiteboard dedicated to planning and team management. We've got whole drawer units dedicated to storage of pieces for the actual competition. We've got workbenches, especially that we're just working the robot on. We've got different monitors, different players, just laptops, like a whole setup ready so that we're competition ready as soon as we can. We're using the board mainly for sort of team management projects at the moment. We've got lists of all our team members and their designated roles at the moment, what they've been working towards, what they're working on. This section we've got sort of sub-teams. We decided it'd probably be easier if we could work out some kind of system that we could divide our members on so that they would all have a project they could be working on before then bring it together with like a main final piece. And it's quite nice. You saw one team working on something a few minutes ago and then another team working on something, and then later on you see them work together to build this one thing based off the two original ideas, which is fantastic to see. We've got our leaders, or the teachers that oversee the project, Diane and Rob, who came to the competition with us. And then we've also got plans for how we're going to have the video go, so that's including things like times, how we're going to frame it, current things that we're probably working on towards putting into it. On the top, the most important part is the deadlines. You see two of them have been crossed on us. It's just so that we know what our next objective is, what we should be working towards getting ready next. What's the most pressing thing that we have to get done? At the moment it's just finish the robot plans, get the video done. Also we've got things like the system lists, things we have to include in the robot, what we should be working on, and how the robot is progressing in different ways. So that's our robotics lab.
Our wider team meets twice a week, and after we received our kit, we used one of these full meetings to familiarise ourselves with the kit and plan how we were going to go ahead. From there, small teams met up in our robotics room whenever they were available to build and test small systems of the robot. Once these were assembled into our first prototype, testing began on the unit as a whole. After designing a second prototype, based on what we learnt from the first, we disassembled our initial prototype and began the next stage of building, testing and refining. Many of our team members are second year sixth formers, so have A-level exams looming on the horizon. By dividing jobs into smaller tasks and communicating on our group chat, we ensure that anyone can make a valuable contribution whenever they are available.
This is our first prototype of our robot. In general, we have decided to have a design where the robot will automatically pick up and sort the balls using the colour sensor. Our original design idea was to have the small wheels on the axles at the front and spin them, and that allowed us to, as shown in this diagram, we hoped it would pull the balls in, under and up, so we could have a similar sorting system as the one here, but we found that you needed to gear it a lot to get the speed needed, and that meant it was more unreliable and the gears were more likely to slip. For our robot we've decided to have a motor for each wheel, which allows us to turn much more tightly, and it allows us more accuracy in driving. However, we have a problem at the moment, since we only have these wheels, that when we try and turn, quite often it will skid and the wheels will sort of bend slightly, and we are hoping this will be fixed once the Omni wheels arrive, as they have not been dispatched yet.
During the design process of our prototype, we learned a lot of stuff about how the kit works and how it all fits together. Primarily, when we made our sorting mechanism, we were going to rely on it being gravity fed. So we had a ramp that went down like this, and the balls would go along into this sorting area here. However, we learned that it's a lot more effective and consistent to just use this polycord here and squish the balls a little bit and have a lot of friction to move them along. So we don't have to rely on gravity. Having the balls be locked in by the polycord helps, especially with the tilted elements in the arena, such as the bridge and the riverbanks, where the balls have a potential to roll back into here and just generally have behaviour we don't want. So having consistency during the game will be a big advantage. Another problem we ran into with this design is we originally thought it would be quite quick at intaking balls, as they can go in here and in this other area here. However, we found out it tends to knock balls away and just generally not accept balls very quickly. And there's also not much storage area before they get sorted, as well as having to stop them being intaked while it sorts them, as otherwise it would just overload the sorting mechanism with too many balls. So to try and fix that, we had a look at other robots, primarily robots in the first robotics competition, to have a look at what sort of mechanics drove their ball mechanisms, as they seemed really quite good at picking balls up. And what most of them seem to use is a bar that goes across the entirety of the front of the robot, with a lot of wheels on them to suck balls up from anywhere along the front of the robot. And we find that design's quite good because you can effectively intake as many balls as you want, as quick as you want. So we'd be quite happy to implement that design.
Hi, I'm Diane. I'm Head of Computer Science at Collyers, and my responsibility is to do all the boring bits. So one of the things I do is the paperwork. Here's my trips folder, and that involves getting all of the permissions from parents and from college for students to attend trips, doing all the health and safety stuff, making sure that West Sussex County Council is happy with our paperwork as well. And all of that is in hand, you'll be pleased to hear.
This is a table we've drawn up to ensure that everyone has the correct paperwork. 7 people, and Diane the teacher, who shall be accompanying us.
So instead of designing the robot all in one big system, we took away the different components and worked on those separately so that we had lots of working parts that we could combine to make the overall system.
We'd like to thank you again for considering us to be the team that represents the UK at the first Global Robotics Challenge. We hope we've shown you how well we work as a team and how receptive we are to feedback and new ideas. We would relish the opportunity to work with like-minded teams from across the world to share our enthusiasm, our passion and collective skills to work on the greatest challenge, or one of the greatest challenges of our time. Thank you for watching, and we hope you choose Team Collyers.